First of all, I would like to say good morning to you. Very briefly, I will introduce myself and then start my presentation. I'm Şaban Ateş at Poliya. I am working as Product Development and Technical Support Manager for more than 15 years. We are producing polyester and resin design, vinyl ester, molding separator, and different solutions are offered and produced for the market. Today in this presentation, I will be taking you through the innovations in the composite technologies. This is how it's going to be like. First of all, brief information about the Poliya company, and then developments and innovations in the molding systems, the latest updates in vinyl ester resins, the solutions for the conductivity in composites, new products, new solutions, and that's how I'm going to finish my presentation. Poliya was established by İsmet Çakar in 1983 in composite resins and in supplies. It has an expertise. It's a Turkish company. And this is the basic approach in terms of the resin development. It's purely based on R&D. It makes custom-made and tailored solutions and designs for the clients. They're trying to maximize their adaptation to the customer solutions. So it's actually functioning as an R&D company at the same time. This is how it's structured. Mainly, this is one of the most frequently questions. Where does the name Poliya come from? Polyester and supplies, and it's the abbreviated form of the Turkish names. As I've told you before, it was established in 1983. It's 100% Turkish capital company. The number of employees as we speak is 140. Headquartered in Avcılar, administrative staff in Tekirdağ, Çerkezköy, We have the production facilities. Turnover is around $85 million for estimated turnover. Turkey's second largest, and it is listed among the second largest 500 industrial enterprises, and we would like to become in the first list very soon in the near future. And it is a member of TKSD, Composite Industrials Association, Kalden and PAGEV. In terms of the quality systems, ISO 9001, ISO 14001, OSAS 18001, and REACH systems are the quality assurance systems of which we have the certification. And with its responsibilities, liabilities, raw material registrations, we are also, with the declarations, we are also within the scope of REACH, which is a chemical regulation of European Union. This is Çerkezköy facility. So it is located on 60 hectares, 35 belongs to indoor area. It's a single location, and it's the largest resin, one of the largest resin producers in Europe and in Turkey. And we have the reactor unit, which you see here. Can't you see it? And here, in this part, with the latest investments, completely automated filling systems. And over here at the top, you see the heat loading, the high temperature loading, which is completely sent through the automated line. So that's how it is handled. And we have the can filling system on the picture. You see that. In this system, the products which are produced without human touch in a completely and fully automated fashion, they're filled, they're packaged, and they are prepared, ready for sale. As I told you before, it has a mainly and essentially R&D oriented approach. So it's not only offering the products to the clients, but we also try to act as their solution partners. That's why we have a very wide range of R&D skills, thanks to which, in line with the demands from the customers, the pilot reactor resin design, we do the resin design, we conduct the tests, and as a result of those tests, again, in line with the process of the client, we offer the best adaptation, not only prior to the sales, but in the after sales, whatever technical support they might need, or if they ever need a test, we simply help them. Another important aspect is color labs, quality control labs, process labs are available in Poliya. From input of the raw material until the final phase, at every point there is a control in every stage, and it is stabilized, it is reproducible, and there is a high level quality in every step and of service we provide. It's a pilot polyester reactor, and we have the color measurement device, and you see the R&D team, which you see in the photograph. So in terms of the product range, gel coat series, high performance gel coats, construction and marine applications, polyester and vinyl ester, DCPD basis, so and so forth. So whatever is used, all types of resins used in the polyester industry. And strand-free, pigment paste, monomer-free, the speaker corrects, pigment paste, chlorine effect, the additives, and the mold separators. We have a very, actually, wide range of products. And Poliya, on an annual basis, has a capacity, used to have a 50,000 tons capacity. With the latest investments, this was increased to 70,000 tons per annum. And 60% of the production is exported to 35 different countries, as you could see. In this respect, Poliya is a global resin provider, and it has its own objective of becoming the largest composite supplier in its region. So it's taking very firm steps towards that objective. And as you could see, United States, Chile, Colombia, Papua New Guinea, Vietnam, and South Africa, at the top, Norway, Finland, are some of the different countries which are using the resin productions of Poliya, and it is the supplier of so many other big providers and manufacturers. So now coming to the main theme of my project. So in the fast molding system, we have a new product, Polypol 324 zero resin, and the gel coat, Polygel P280. A decade ago, we started to receive such demands from the industry. Well, as you know, one of the biggest problems of polyester is that it shrinks. So size-wise, it's getting smaller. Because of that problem, particularly the mold generators, producers, had a problem. So they design it, they create the model. However, because the mold shrinks, then the sizes do not match. In order to prevent that problem, there are so many different methods. So you have to allow some percentage in the same level that it's going to shrink. And the second thing is that to make sure that the polyester does not shrink, there's going to be very slow lamination so that that problem would be eliminated. However, all those methods failed, both technically speaking or labor-wise or quality-wise. They were not delivering the results. So we wanted to have fast molding. We wanted to eliminate the shrinkage. We wanted to have an overlapping 100% match. We wanted to offer high quality. And in terms of time and labor, we wanted to save. So a decade ago, with 300 we produced this fast mold design, and it has been used very safely in the industry for quite a long time. However, then we started to receive some other demands. Well, we wanted to have better wetting and better mechanical values, a better ventilation, and we want them to have lightweight, more lightweight. That's why we wanted to simply produce a new generation of mold and gel coat. In the conventional system, as I've told you before, a mold design would take, give or take, 10 days, because lamination for 10-15 times, and you have to proceed by 2 coats at a time, and you have to go rather slow. You have to do simply the sanding, and you're going to come up with the mold, and then an application which was rather full of surprises. But thanks to the system, this 10-day period was reduced to 1 day, at the end of which you would have the molds ready to use. So 300, what's the difference of 324 from the other ones? So 324 is more lightweight. So the molds you produce are more lightweight. And I'm going to talk about this in a minute. In one single go, thick or thin, 5 or 6 layers, wet practice, a wet application or non-wet application, and you have 100% match. The mold and the whatever you have, there is zero shrinkage, and it's the gloss and the surface is not impacted by anything, any other factor, and you have a very high surface quality, and you're very fast. So it's actually a great advantage in 1 day, and with the reinforcement of the other thing, from the boat to the wind turbine blade, you have so many different sizes and types of molds, and you could go very fast in this respect. These are the mechanical properties of Polypol 324. Viscosity is around 800, 900. So the fiber performance is very well. And with the fiber performance, in terms of the air bubbles, in terms of driving the air bubbles away, it's very good. Gel period, I'm going to show that. It works in a very wide range. 20-30 minutes, you have the gel period, 2% peroxide, HDT temperature. In the previous system, it used to be 95. In this system, it is resistant up to 105 degrees, which means that it's great, and shrinkage resistance is 120 megapascal. So the tests were done with 5 layers of glass fiber, and the module is rather good. 6500, 4% elongation, and 204 megapascal resistance against the elongation, and resistance against damage is 25 megapascal. So as I told you before, much better wetting in terms of the mold. They're more lightweight, and you have much better heat resistance and zero shrinkage, and much better and more superior surface quality. So Polypol 324 gel graph could be seen here at different peroxide levels. As you could see, between 1 to 2.5% peroxide make from 20 minutes to 1 hour. It allows you to work in a wide range of time. So I would like to have a recommendation for you. As you know, in composite applications, and particularly in composite, it's also important in the other mold applications, ambient temperature should not be lower than 20, but definitely not lower than 15 Celsius degree if you're going to work with moods. In winter, it is 2.5%, and in minimum, it's 1% peroxide. In summer months, you could work with such applications. And as you could see on the screen, based on the desired gel type, you could get to choose your peroxide level. So what we recommend, methylethane ketone peroxide with M65, you could have an ideal application. The other aspect, well, I'm going to come to that in a minute. One of the biggest advantages of the system is normally in these systems, thick lamination is recommended. But here you could also do the thin lamination, 2 layers or 4 or 5 layers of fiber. You get to have the same results. So you could work with your molds. Particularly in some of the big molds, we have such questions. I'm going to talk about this. 4 layers, 5 layers, particularly in the boats or the marine vessels. Once you reach from one end until the end, the time is not sufficient. And sometimes this is what we are asked by the clients. We have a huge mold, and it's not possible or feasible for us to do that 5 times. So in this system, even if you do it 2 layers, you get to have the same results and performance. Additionally speaking, as I've told you before, well, this is 40 barcode. Thickness is rich, and this means it's ready to use. You don't have to additionally wait for a longer time, thanks to the accelerating system. And with that system, a new gel coat is also offered to you. High performance molds. There are some essential problems. What are those problems? Particularly when they are exposed to RTM infusion applications, when they are exposed to high temperatures, the composite lamination temperature becomes 80 or 70 Celsius degree. Throughout that temperature, gel coat on the surface, because of the temperature and because of the strain, and the other solvents are losing their surface varnish or gloss, and there is this deterioration in that surface look, and when it receives from the edges, there is this cracking when it receives damage or blows. So these are the technical problems. Polygel P280 is vinyl ester base. Thanks to that vinyl ester structure, particularly against solvents, it is highly resistant. It is highly resistant against strain, and 115 HDT value, which means that in high temperature applications such as RTM, it is going to have a high level of resistance, and the surface quality is actually superior at the end of the application. So you probably know this, but I would like to remind you once again. While you are using a brush or spraying for the gel coat application, the spray gun waiting between the layers, peroxide, and before that waiting time before the lamination, the performance out of the mold that you're going to use, it's going to be significantly higher. Particularly in the high performance molds, with 280 gel coat. After that, these are the steps. After the gel coat application, 1 layer vinyl ester skin coat, so it's like an intermediary layer which is applied, and it's either the surface tulle or we use the fiber. So sometimes in clients we see that in gel coat 415 or 600 fiber is what they start with, and they have direct repercussions on the surface quality. So you have to start with the fiber with lower grammage, and that is going to directly impact the aesthetical look of the layer. After the application of vinyl ester, curing, you wait for it to be frozen, you wait for the curing, and with 324 4 layers or 5 layers, with a thickness of 4 to 5 millimeter wet on wet, without ever needing to wait, or without a concern that it's going to shrink, you could do these steps following one another. After this application for 5 layers, you wait for the part to cool, which means that the temperature falling to the ambient temperature, and then until you reach the thickness, wet on wet, 4 or 5 layers of application is what you could continue with. I would like to remind you one thing else. If you are going to exceed 24 hours with your application, which means that you do your application and you sometimes you just let it go and you have to come back. So before the practice, before the application, with the sandpaper, which is 60 or 80, just do prior work so that it's going to increase the performance. And then, as I told you, whatever you would like to do, 10 times, 15 times, you could work on your surface. The other product which I would like to share with you in this presentation is Polygel P218 R static conductive gel coat. As you know, in the polymer composites, they are not conductive. Their electricity and heat conductivity is rather low. That's why in so many applications as insulation material, they are used. However, in some applications, this feature could be rather problematic, particularly because of that non-conductivity. There is this accumulation of static power, static load, and that static load is preventing the easy takeoff of the mold, or there could be the accumulation of dust in the molds. Or these composite plates, when they are used as an insulation material, there could be spark or safety-related complications. So that's why people are looking for a conductivity solution. There have been a number of solutions until now, but because of the performance or in terms of the features of the final product, they were not sufficient. So single wall carbon nanotype was combined with this material in order to give conductivity to this gel coat. With that conductivity, the static load accumulation, or wherever you would like to have a certain conduction, we offer the solution. So here, in Polygel P218, this could be used additionally. So because you could have grounding because it has an anti-static feature, and it has the advantage of more glossy surface. It does not allow dust accumulation, and it could be also used for the heating systems in the molds. It could offer an alternative in that respect. The other series is, as you see, for almost more than 15 years, we see the production of vinyl ester, and with acrylic or metacrylic acid, there's a reaction which creates this class. and it has some added advantages compared to the other polyester. Because of the chemical structure, it has resistance against water, and because of the structure, it has a resistance against the chemicals, and at the same time, it has high mechanical resistance, and the elongation values are also very much for the advantage for the composite industry. So it is, as you know, in this series, 700 performance applications, 701, 702 infusion applications. Maybe we might have college students in your toolboxes, particularly in the structural bodies, in the infusion applications. In combination with vinyl ester, you could use this polymer concrete, chemical waste treatment, polymer concrete, polywaste 703, Breton stone applications, polywaste 704, pultrusion applications, polywaste 709, and flame retardant applications 710, high performance vinyl ester, polywaste 711. So for quite a long time it has been used. So here I would like to talk about two solutions. Polywaste 710, it's flame retardant vinyl ester. It's flame retardant, and it's not because of the additional fillings, but it has that innate raw materials which is very much embedded in its structure. And particularly, where shall we use this? I would like to now share information with you. Where the chemical resistance, the strength resistance, and the feature, the flame retardancy should be combined in one single solution. You have a boat, for example, and that boat, you want the boat to have strength, you want it to be flame retardant, you want it to be water resistance, or you have built the fuel tank and you would like to have additional flame and fire related precautions. That's why you might want to use polywaste 710. You might want to combine it with RTM or infusion, or you might want to use it for some different applications, different solutions for different applications. Polywaste 710 has a limit oxygen index of 25%, but in combination with antimony, there's a synergistic value. It could be 34% Lloyd value, which means that British standard BS 476, it corresponds to class 1 resin. And also we have to note that there are so many inflammability standards, DIN 5510, 45, 545. There are so many standards. And again, this is corresponding to those features in those different classification standards. As I told you before, based on the project, based on the final properties of the product, we could adapt and use this vinyl ester. Very briefly, I would like to talk about the mechanical values of polywaste 710. Viscosity is 400, 500 centibois, 34 to 38% monomer. Gel period is 20 to 30 minutes. Alcohol value is 135. HDT value is 110. Which means that if you require high temperature, in terms of the flame retardancy, it is also a very good fit. You get to see the Lloyd values here. According to ISO standardization, it's 25. With antimony, it corresponds to 34. And over here, you get to see the DMA graph, there is this degree which is loss modulus and storage modulus values. So there is a sharp decline. That's where we have the glass penetration value. The other vinyl ester which I would like to share with you is Poliya 709. People in the industry would know that, particularly in hot press applications, vinyl ester has a number of things to improve in SMC or BMC, in pultrusion applications. Curing them, molding them is rather delayed. It takes some time. But this vinyl ester, which we developed with this new product, new solution, Poliya 709, for the protrusion applications, in line with the molding temperatures and shrinking ratios and high mechanical structure features of vinyl ester and elongation features are simply protected. Particularly, this has been designed for the wind energy applications, and with the strength, the fatigue resistance are playing an important role in this product. And in terms of fatigue resistance and fatigue resistance properties, this is a great fit for the wind energy applications. And in terms of thermal shock and chemical properties, I'm so sorry. It has been actually a rather good design. And in the last part, you see the combination, the SEM look, SEM look, in combination with carbon fiber. One of the biggest properties of vinyl ester is, in combination with glass fiber, it has a high compatibility with carbon fiber. Polyesters, when they're used in combination with carbon fibers, there could be delaminations because of the compatibility problem. In glass fiber with epoxy, vinyl ester is intensely used. You see on the level of SEM, vinyl ester are surrounding the carbon fibers, and it is openly and obviously showing the adhesion surrounding the carbon fiber. Last but not least, Poliya 709 mechanical properties. You get to see them here. HDT temperature is 115 and pull strength 90 megapascal. Elasticity module 3200, and the curve strength is, elongation is 7.9, and blow resistance 16 kilojoule. So these are very high numbers, to tell you the truth, and reaching those numbers with polyester is not feasible. And as I've told you before, because this is used in wind energy, it has a very high level. It is a very high level of vinyl ester.